How many points xy with x and y both integers are on the line with equation y equals 4x plus 3 and inside the region bounded by x equals 25, x equals 75, y equals 120, y equals 250. So we have a line somewhere, and we've got to basically find integer solutions. So let's draw this like entirely based on the boundaries that they've given me. So we got 25 and 75, so approximately here and here. And this won't be drawn to scale, but 120 and 250. So approximately something like that, where this is 25, this is 75, this is 120, and this is 250. And then now let's plot this y equals 4x plus 3. When x is 25, we're going to have a 103, so approximately here. And when x is 75, we're going to have 303, so somewhere here. And then let's connect those two lines to get an idea of what this will look like, so something like this. So now the equation has to be looked at in terms of these boundaries. So let's just make a little table for ourselves, x and y, and off we go. So they want it inside this region, so we obviously have to go above 25, so let's go to 26. When x is 26, when you plug it into that equation, we get 107. When x is 27, we get 111. When x is 28, we get 115, and so on, right? 29 will give you 119. So far, my x is within that boundary, and my y's are within that boundary. Well, not yet, right? Because 119 is not 120. I got to keep going. 30 gives me 123. Now I can say I am within my boundary for both x and y. And then we just keep going like this, dot, dot, dot. And then eventually you can kind of figure out, when will I get beyond that boundary? And you go beyond that boundary when y is above 250, right? 250 or equal to 250. So that basically means that 250 is going to be equal to 4x plus 3. So that means 247 is equal to 4x. So x is equal to 61.75. So that means that once you get above that, you're going to get beyond the boundary. So if it's 62, if we plug it in, it becomes 251, and indeed we are above that boundary. So 61 is 247, and we're still within our range. So that means these values are the ones that are within the range, and we have to just count them up. So it's all the integers from 30 to 61, so that's 61 minus 29, and that is 32. So number 21, the answer is D. A dot starts at 2019. It can move 1 unit vertically or horizontally to one of the points 2119, 1919, 2020, or 2018. From there, it can move 2 units in either direction that is perpendicular to the first move. All moves thereafter increase in length by 1 unit. 3 units, 4 units, 5 units, etc. And then must be perpendicular to the direction of the previous move. The dot stops after 10 moves. Which of the following final locations is not possible? So let's talk about this. We are starting at 2019, right? That's the coordinate. And then we have to complete the full 10 moves. The dot stops after 10 moves. So we've got to go through all 10. Now at each move, it's either 1, 2, 3, 4, and so on, in terms of how much it increases or decreases by, or not at all. Now, for each of these, it could either go up across in the x direction, or it can go up or down in the y direction for 1, 2, and so on. And it can either go plus 1, minus, or 0. Similarly, plus, minus, or 0. Plus, minus, 0, and so on for each of them. Okay, so we have to figure out of the answer choices which one is not possible. So this is one of those painful trial and error if you've got a system, by all means use it. So let's talk about this one at a time. Let's start with answer choice A. Our xy has to go to 2733. So that means my x, we started at 20, so I've got to go plus 7 for the x. And for the y, it looks like plus 14, right? Okay. So how do I get that? Well, I'm going to go 1 plus 1, that is. For the x, I'm going to choose a plus 3 here. Plus 5, a plus 7, and a minus 9. That would bring me to 7, right? Because it's 4, 9, 16, and then 16 minus 9 is 7. Okay. Now, when I choose those, these ones have to be 0. Because remember, I can only go in one direction. If I went up, I'm not going to go left or right. If I went down, I'm not going to go left or right. If I go left, I can't go up or down. If I go right, I can't go up or down. So if I choose a horizontal move, then the vertical move is 0, and vice versa. Okay, so now let's talk about the y direction, which is going up or down, which is vertical. It would be obviously involving the 2, but it would be minus, involving the 4, plus, minus 6, plus 8, and plus 10. If you add up those, you get 18, 4 is 22, 22 minus 8 is 14, and that's what we have. So as you can see, we've got to figure out this, and when we do, we can see that 2733 can be reached. So therefore, it is possible, so that's not the answer choice. All right, so let's keep going in the exact same way. 30, 40 is the next one. This time, I've got to go 10 plus and 21 plus for the x and y directions. And let's see, how do we make this one? For the x, it's going to be plus 2, minus 4, minus 6, plus 8, and plus 10. That would give me 18 minus 10, or 22, or 20 minus 10. I can't even add. 20 minus 10, and that gives me 10. Okay, now I've got to figure out the y's, right? So the numbers are 1. I don't know plus or minus. I'm just going to write the numbers. 1, 3, 5, 7, and 9. And if you fiddle around with these, you'll find there's no way to get a 21. No matter if it's plus or negative, it's got to be plus or minus. It can't be 0, because remember, these are zeros up here. So we've got to have either a plus or minus for each of these. And you'll see when you fiddle around with that, there's no way to get 21. And therefore, because there's no way to get 21, this is not possible. So because it's not possible, that is the answer. And just for the sake of completion, I will write out the ways to get the other 3 choices, which are 21, 21, 42, 44, and 37, 37. So here we go. For 21, 21, that's what? Plus 1 and plus 1. So that's pretty straightforward. And therefore, it would be 1 minus 3 plus 5 plus 7 minus 9. And then in the y direction, plus 2 plus 4 minus 6 minus 8 and plus 10. So that is what? Plus 2, which is what we had to do because we had to go from 19 to 21. So it actually was plus 2. All right, for this guy, 22 and 25, x and y. And that is the combinations to get the 22 and 25. And the last one is plus 17 and plus 18. And that is how you would get those. So it's really a lot of trial and error, and I really commend those students who got this correct because it's actually quite time-consuming to go through every single possible way of getting this and getting that. And so hopefully that made sense, and therefore number 24, the answer is B. On a coordinate grid, Paul draws a line segment of length 1 from the origin to the right, stopping at 1, 0. He then draws a line segment of length 2 up from this point, stopping at 1, 2. He then continues to draw line segments to the right and up, increasing the length of the line segment he draws by 1 each time. One of his line segments stops at point 529, 506. What is the end point of the next line segment that he draws? Well, if you look at this diagram, they've drawn obviously just the first few. And in particular, if you look at any point x, y, what will it be? Well, the x-coordinate looks like it'll be 1, and then 1 plus 3, 1 plus 5, and so on, right? So the x-coordinate will be 1 plus 3 plus 5, dot, 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 and so on. Whatever we end up until. And let's say we go until n. I don't know how far we're going, right? When I get to here, I'm not sure yet how far I have to go. But that's what the x-coordinate will be. The y-coordinate, if you look at it, it'll be going up. So 2 plus 4 plus 6 and so on. So 2 plus 4 plus 6 and so on until we get to some value. And again, I don't know what it is, so I'll just call it m. But one thing I do know is that n and m are very close together. They're only 1 apart. For example, if n was, say, 5, m would be 6, right? So I'm not 100% sure yet, but n and m differ by 1, so let's just say n is equal to m minus 1. It could be off by 1. It could be n is equal to m plus 1, but this is a pretty decent start. Okay, so now they give us the big clue that eventually we're getting to 529 and 506. All right. Well, there's a quick way of doing this question. There's a longer way. The longer way sort of explains it a little bit better. And I'm going to do it the longer way just because I want to explain it a little bit better. But on a math contest, you do it in the shortest way possible. So, because I want to explain it, I'm going to take this point, 529, and in a very straightforward way, assign this to be x and this is y. So this 529, since it's x, I'm going to use that formula. So 529 is equal to 1 plus 3 plus 5 plus dot, 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 until some n. And 506, since that y is 506, that's going to be 2 plus 4 plus 6 plus dot, 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 all the way till some m. All right. Now, you guys have a calculator. It's allowed on the exam. Some of you can easily just do this on a calculator. You can just get out and 1 plus 3 plus 5 plus 7 plus 9 plus 11, dot, dot, dot. Keep going until you get to 529, and you'll be able to figure out your n. And then you can do the same thing here, 2 plus 4 plus 6 plus 8 plus 10, and you can easily get up to m. But these are kind of big numbers, right? They're not extremely big, but they're sort of big. So what I'm going to show is a formula. The first formula I'm going to show you is this one right here. When you have this kind of scenario, it's not consecutive numbers, it's consecutive even numbers. So we can factor out the 2. And when you do, you get 1 plus 2 plus 3, that like that. And that is consecutive numbers. The 1 plus 2 plus 3 part. So that goes all the way until now m over 2. And this part has a formula. And some of you may know it, some of you may not. It's in grade 7. So you're in grade 7, so you may not know that the sum of consecutive numbers, dot, 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 until n is equal to n times n plus 1 over 2. All right? So using that formula here, this part becomes m over 2 times m over 2 plus 1 all over 2. All right? So that basically, these 2's cancel out. So you just have m over 2 times m over 2 plus 1. And that, of course, equals 506. Now, at this point, I do not encourage you to multiply it out and do use a quadratic, all that stuff. Just use inspection. Get out your calculator, take the square root of this, and see what two numbers multiplied by each other equal 506, right? And those two numbers are consecutive. So do a little bit of fiddling around. When you take the square root, you'll see that it's about 22 point something, right? So I think that m over 2 is possibly 22. Well, let's see. Take out calculator, take 22, multiply it by 23, and indeed it is going to be 506. So there you go. M over 2 is indeed 22. So that means m is 44. Perfect. All right, now go back. Remember in the beginning I said that n is 1 away from m. So if m is 44, n is perhaps 43. So now I've got to go back to this formula and figure out what is x. Okay, no problem. X is 1 plus 3 plus 5 plus ... all the way until n, and that n I have chosen to be 43. Again, I would like to show you a formula. You can do this in a calculator without a formula. Formulas are not necessary, by the way. I'm not saying you need to, but it just makes it faster and also helps you learn a little bit more. The formula for this now, these are not consecutive numbers. These are consecutive odd numbers. That is not going to be this formula. It's going to be something else. And that formula is a little lesser known. This one is very well known. But the consecutive odd numbers, that one is a little lesser known. That one is n plus 1 times n plus 1 all over 4. And even if you didn't know this formula, like I said, don't worry about it. You can easily do this on a calculator. The 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 and so on all the way up until 43. If you do that, you get 484. Now you say, oh, that's not 529. Okay, no problem. All that means is that I just have to add one more because n is not 43, n is most likely 45. So add another number, and when you do, you get 529. So let's illustrate this in a very, very brief diagram. So that means we had a scenario as follows. We went this way, right up. We kept going right up. And then what happened was, let's just fill this in. We had 41 here, 42 here, 43 here, 44 here, and then 45 here. That's how we got to this point right here, which was our 529, 506. And now if we keep going, we're going to go 46 up to get to this point. And they're saying, what are the coordinates of that point? Well, if you go up 46 from this point, the x-coordinate doesn't change. It just remains 529. But the y-coordinate definitely changed. You have to add 46 to the y-coordinate. And when you do, you get 552. So that is going to be the endpoint of the next line segment that he draws. And therefore, number 25, the answer is A. Each diagram shows a triangle labeled with its area. What is the correct order of the areas of these triangles? So for each of these, we've got to figure out the area. So let's start with M, which is the first one. The area, of course, will be the area of the full square, which is a 4 by 4 square. And then from that, we have to subtract these smaller triangles. So we have to subtract this one, and this one. And when we do, we will be left with the area of that triangle that they have labeled as M. So let's do that math. So that's going to be 1/2 base times height, 1 times 4, and then 1/2 base times height again, 1/2 3 times 3, and 1/2 base times height, 4 and 1. So this is going to be 16 minus 2 minus 4.5 minus 2, and that is 7.5. So that's basically what we have to do for n and p. Pretty much the same thing. So for n, again, it's going to be the full square, And then, of course, we have to subtract this triangle, and this triangle. And when you do, you will have this remaining, which is the area of n. So 1/2 base times height, 4 times 3, 1/2 1 times 4, and 1/2 3 times 1. So this will be 16 minus 6 minus 2 minus 1.5, and that is 6.5. And then now we have to do pretty much the exact same thing for P. And by now you get the hang of this. You're just subtracting 3 triangles. So it'll be 4 times 1 here, 1/2 2 times 4, and 1/2 times 2 times 3. And that is going to be 16 minus 2 minus 4 minus 3, and that is 7. So M is 7.5, P is 6.5, P is 7. So the correct order from smallest to largest, the smallest looks like it is N, because that's 6.5, and then next is P, and then next is M, from smallest to largest, and less than P, which is less than M. And therefore the answer to this question, number 21, is D. In the 4x5 grid shown, 6 of the 1x1 squares are not intersected by either diagonal. When the 2 diagonals of an 8x10 grid are drawn, how many of the 1x1 squares are not intersected by either diagonal? In the first one, let's look at which 6. This one, these two, and this one. Those 6 are not intersected by the diagonals. Now, they are then giving us a much bigger one, and they're saying, okay, we've talked about the 4x5, but now we want to look at an 8x10. Well, what's interesting about an 8x10 is it's exactly 4 times the one that they gave originally. So approximately like that. If it's 8x10 in full, 8x10, then each of these would be 5x4. So we really can just look at this 5x4 and then multiply the answer by 4, since this is just 4 of those. But the difference is that now we're looking at diagonals for the whole. So we're looking at diagonals that go all the way across the entire one. So that would be the equivalent, really, of just looking at a diagonal like that. So only one diagonal, and then counting how many squares does it touch and not touch. Well, it touches 1, 2, 3, 4, 5, 6, 7, and 8. So crosses or touches, whichever term you want to use, crosses 8. So it does not cross 12. So if it does not cross 12, then it does not cross 12 here, does not cross 12 here, here, and here. This rectangle, this rectangle, this rectangle, this rectangle. So in total, it would not cross 4 times 12, which is 48 of these tiny squares. So number 21, the answer is D.